This next topic, we're going to be discussing solving a linear equation where we have multiple occurrences of the variable. Okay, um, these can oftentimes appear quite messy, but like everything in math, usually if you break it down into smaller pieces, it oftentimes ends up being really pretty simple. Okay, and this is no exception to that. Okay. So let's say maybe you're given something that looks a little like this. We have negative 2 times negative 7x plus 9 minus 4x is equal to 2 times x minus 9 minus 2. All right. So what's nice here is, I guess not nice here. This looks messy. Okay. I guess I'll start by saying that this looks messy. If you've never seen something like this before, it might be kind of intimidating. But I would just encourage you to take a deep breath, look at this, and try and simplify it as much as possible. So the first thing we do here is we think of our order of operations. Okay. Hopefully, we've all seen this before. PEMDAS. We first deal with parentheses, then exponents, then multiplication, uh, division, addition, subtraction, right? This is the order of operations that we do here, okay? So the first thing we look at is we notice there are parentheses. Can we simplify anything inside of the parentheses? It doesn't appear so, okay? So inside of the parentheses, we don't really have anything here. But outside of the parentheses, we're dealing with some multiplication involving those parentheses. So let's deal with that first. So you'll notice here we have negative 2 times negative 7x plus 9 in parentheses. We're going to distribute this negative 2 here, okay? So we'll have negative 2 times negative 7x. That's going to give us positive 14x, okay? And then we'll have negative 2 times a positive 9. So this will give us a negative 18. So 2 times negative 7x plus 9 in parentheses simplifies to 14x minus 18. And then we have minus 4x here. Now on the right-hand side, very similar. You can't simplify anything inside of the parentheses there, but we can distribute this too. So let's do that now. So we'll have 2x. So if 2 times x is 2x. And then 2 times negative 9 is, again, that's going to give us a negative 18. And then we'll have minus 2. So now what we can do is we can combine all like terms on each side of this equation, okay? So we'll combine all of our constants together on each side, and we'll combine all of our instances of x on each side. So on the left-hand side, the first thing we notice is we have a 14x and we have a negative 4x. So let's combine these two. 14x plus a negative 4x will just give us 10x. So the left-hand side here is going to become 10x minus 18. Okay? On the right-hand side, we have a negative 18 and a negative 2. So if we combine those, we'll have negative 18 plus negative 2. That's negative 20. So we'll have 2x minus 20. All right, so now we want to try to get the x, all the x's on one side and all of the constant terms on the other. All right, so let's go ahead and bring this 2x over to the other side. So we'll take 2x away. These will cancel, and we'll have then ax minus 18 is equal to negative 20. Now we can add 18, and we're going to get then that 8x is equal to negative 2. And if we divide both sides of this equation by 8 in order to isolate x by itself, these will cancel, and we'll get that x is equal to negative 2 over 8, or we get that x is equal to negative 1/4. Turn off my notifications here. All right. So now we have that x is equal to negative 1/4. Now, if you want to, you can go back and you can plug in x equals negative 1/4 just to ensure that you did all of the arithmetic correctly. Again, I'm going to skip that here, but I would encourage you just as a basic exercise to go back and do that just to make sure that that's actually right. Let's try another one. Let's say that we're given 3 times x plus 7 in parentheses. That's going to be equal to negative 3 times 4x minus 8 plus 6x. Okay, looks fairly similar to the last one, so we're going to follow kind of the same idea. Doesn't look like we can simplify anything here, so let's go ahead and do our distributions, okay? So let's take this 3, and we're going to distribute this to our x and to our 7. So we'll have the left-hand side here is going to become 3x plus 7 times 3, so that's 21. So 3x plus 21. And on the right-hand side, we can go ahead and distribute this negative 3 to the 4x and to the negative 8. So now we'll have minus 12x, okay? And then we'll have negative 3 times negative 8. That's going to give us a positive 24. So we'll have plus 24. And then we still have this positive 6x off here to the side. Cool. So now let's go ahead and combine like terms. The left-hand side looks like it's about as simplified as it's going to get, at least for now. The right-hand side, we have a negative 12x and we have a positive 6x. So if we have negative 12x plus 6x, that'll just give us negative 6x. So this will become 3x plus 21 is equal to negative 6x plus 24. All right? Now, again, we're looking to get all of our x's on one side and all of our constant terms on the other. So let's go ahead and add 6x to both sides of this equation. Okay? These will cancel, and we'll get 9x plus 21 is equal to 24. Okay, now you might wonder why I chose to bring the negative 6 over instead of the 3x over to the other side. The reason is that if you can keep the side where you have all of your x's positive, that's usually better. But you can't always do that, but whenever you can, it just means there's one less thing you have to worry about when doing your calculations. You don't have any pesky negative signs to worry about. So I like to keep the instances of x positive whenever I can. Okay, so that's my justification for that. But here now we have 9x plus 21 is equal to 24. So we can take 21 away from both sides in order to get rid of this 21. Okay, so now we're going to have 9x is equal to 24 minus 21, or we just have 3. So here we can divide both sides by 9 in order to isolate x by itself. These 9s will cancel. And now we're going to have x is equal to 3/9, and we can just simplify that to 1/3. So there we go.